Do the words electrical troubleshooting and chasing trouble codes endlessly in loops delight you? Because they piss me off. If that is the case, this video is for you. And if you ever wondered what the heck all of these wires and cable and crap is on top of the engine, this video is for you. In this video, I'll show you what all of these sensors and gizmos and things are. This is not a replacement for a thorough electronic troubleshooting with a computer at the dealership, but this can save you hundreds or thousands of dollars in electrical troubleshooting, because dealerships with their sophisticated equipment charge big bucks. So the easiest thing to do that you can do, especially on electrical components that only have two wires, is measure resistance. You grab yourself a multimeter and measure resistance. I'm gonna use these little alligator clips so I can talk to you and explain stuff about stuff. Alright, here is my, I only removed two things: the air filter's upper box, they clip come loose, and two hose clamps. I loosened one there, I loosened another one there. That hose clamp there. Okay, you can do this, your 5-year-old kid can do this. And I disconnected, of course, that single hose that seems to be leading to the top of the crankcase. And from this mounting point here, I pulled out this sensor thing there. Okay, we're gonna go over everything. Alright, I don't want to fry the battery. I'll put it on the ground because we just need to look at some of the sensors down there. Super straightforward. All you need is this 10mm wrench, but all I need, and Phillips number 2. What I've got here is the engine. I got stickies on it, and I'll show you the resistance measurements on all of these stickers. It's gonna be a process. Come along. You'll probably find valuable information, depending on the system you're working on and whatever your trouble code is and whatever is bugging you. My color coding: intake system components are black, exhaust system components are blue, fuel supply and fuel delivery to the cylinders is red, and control, whatever that is green. All of this stuff is coming out of the service manual. I went to not the user's manual, okay? Not the 50-page, this big little booklet that you kept in the glove compartment and was lost by Aunt Sally 14 years ago. Not the tourist edition with a clipboard in your hand. No. The service manual, the first volume is this thick, so that's 2,500 pages. 2,000 pages because they are thick and loose. The second volume is also this thick, also 2,000 pages, and on top of it you got an electrical book just on circuit diagrams and everything. So that's 22 to 2,500 books. 2,500 pages in 3 books. Okay, that's where all of these numbers are coming from. You can find these in your library. Hope your city or municipality, wherever you live, actually invest in buying stuff like those. Not coming from the Hayes manual on other or any other hobby books either. Forget the Hayes and whatever Climber, whatever manuals. Those are for the hobbyist who doesn't know how to take off a rear wheel. Forget about it. This is actually coming from the Mazda service manual. So we'll get started on the intake side, where air is being sucked into the engine. The first two sensors are mounted yonder on the lid of the air box. Here is sensor 1 and here is sensor 2. I'm gonna get you a close-up, just hang in there. This one has, okay, how do I do this? Okay, I'm gonna get you off the tripod now. It's gonna be on and off, just bear with me. This one has 3 wires to it, and that sensor lives there. Where's my head flashlight? there in the middle of the circle, between the two bars, there's a little plastic little thing sticking up. That little thing is mass airflow sensor. Okay, 3 wires lead to it. The other guy is this, just sticking in there. It pulls out really easily from the air filter, really easy. Alright, I'll show you that is really easy here. There, that would be the, pulls out really easily. That is the intake air temperature sensor, and I need my knee to hold against. Good. Intake air temperature sensor has 2 pieces of wire leading to it. Maybe without the flashlight. There, those 2 wires, those are their colors. To measure resistance on the 2 wire components is really easy because you only have 2 terminals to choose from. The 3 wire systems are more complicated. So the specs for the intake air temperature sensor are those. Resistance can be measured at room temperature, and in that case it's 2 to 2.9 kilo ohms of resistance, or at warmer temperature the resistance of the sensor drops to 0.27 to 0.37 kilo ohms. Likewise, if you put it in the freezer to minus 10 Celsius, minus 20 Celsius, the resistance should rise ballistically. Okay? It is a temperature, it's a piece of metal that changes its resistance according to temperature. So if you put it in the freezer, that resistance should rise exponentially, significantly. The mass airflow sensor, we're done with the intake air temperature. Next one, mass airflow sensor. It's complicated. You do need a computer to hook up to it, and let the computer do the talking. You have to measure voltage, not resistance. The mass airflow sensor delivers a certain voltage to the computer in the car, and it has to be measured between specific circumstances of vacuum. Super complicated. Don't bother. The next item that we're looking at, since this black rubber hose is removed from here, now you have the, I'll tell you about it in a sec. Now we're looking at the throttle. When I step on the gas, this is what happens, alright? The throttle valve opens. Here you see something with 3 pieces of wire. That one, 3 pieces of wire. This might get closer. Those are the colors. And it goes to the, it's mounted on the same axle as the throttle valve is mounted on. Okay, it's one straight direction. This is your throttle position sensor. The other one that's near here is this. This one has 2 wires to it, one brown, one white. This is your idle, sorry, the idle air control sensor here. This idle air control, 2 pieces of wire, super easy to measure resistance. It should be between 7.7 to 9.3. That's not a 0, that's ohm, 9.3 ohms at 23 degrees. The throttle position sensor is tricky as it's got 3 terminals, A, B, and C. Now, A, B and C could be this way, and so in this way, my index finger is A, or it could be looking at this way, and in that case, my ring finger is A. In any case, B is in the middle. The resistance between A and C, end to end, doesn't matter which one A is, which one is C, is 4 to 6 kilo ohms, so that's 1000 ohms, 4 to 6000 ohms. Between A and B, it's 3.2 to 4.8 kilo ohms, and between B and C, it's 0.2 to 1.2 kilo ohms. Alright, that's throttle position sensor. The next one lives. The next one is this little thing that I unplugged from the top of the rubber hose that was sitting here. It's got 2 pieces of air line going into it, and a sensor that has 2 pieces of wire of that color. Super easy to measure resistance on it. That one is the purge solenoid valve, part of the exhaust system. Its resistance should be 22 to 26 ohms. Next item, underneath, I need my head flashlight. Underneath the throttle body is something, that black thing that you're looking at. Alright. And I need my, this is an Egr valve that you're looking at. I'm trying to get this hose out of the way. You're looking at a black circle there, a black circle with a gray connector plugged into it. That circle, this rub, to get that right, yeah. I can put my hand and camera into it, or down there. The connector for it is big, and it's got 6 wires coming to it. You can't really see all 6 of them, no matter how hard I try. Believe me, this is retake number I don't know anymore. So there is the connector for it. 6 pieces of wire are going to it. That is your Egr valve. We're looking at the Egr valve sticker here. Part of the exhaust system. Egr stands for that, exhaust gas recirculation. The 6 terminals are labeled AB, CD, EF. It's a 6-pin connector. The resistance should be between 20 and 200, between 20 and 24 ohms. When you measure it between C and E, C and A, D and B, D and F. No more combinations, okay? But in all combinations it should be 20 to 24 ohms. Egr valve, part of the exhaust system is blue. End of story on that one. The next batch is a lot easier. This one here, on top of the engine, is this color, 2 pieces of wire, one black, one red with white tracer, or white with red tracer, whichever way you look at it. Let me just get my flashlight. It's getting dark. There, this is what we're looking at. That's how the item looks like. 2 pieces of hoses going into it and an air filter on it. That's an air filter, little thing. It kind of spins, or there, it can spin. This is a PRC solenoid valve, pressure regulator control solenoid. The pressure regulator is here on top of the, at the end of the fuel line, pressure regulator, and that's the pressure regulator solenoid valve. It's straightforward, 2 pieces of wire go into it, and it should have 22 to 26 ohms of resistance to it. Next one, next 2 actually, will be this guy with a white connector. Yeah, a little bit of light here. This guy with a white connector and 2 pieces of air lines going into it at this end here. There's the 2 pieces of wire. And this one also 2 pieces of wire, and the same air lines seem to be going to it. I'm going to disconnect one, say this one, there, and I'm going to measure resistance on it. Those are the terminals that you can see there. 2 metal terminals, and the plastic, that is the rib in the middle. And I'll show you how this one goes. Oh, the resistance on both of these items. Okay, let's see. The names are, those are the names for it. Good luck pronouncing it. That's VICS and VTCS solenoid. VICS stands for Variable Inertia Charging System. That's its resistance. And this one is Variable Tumble Control System. That's its resistance. This one is not a typo, that one is the same, not a typo, and that one was also the same amount, not a typo. I checked, double checked and triple checked, and I spent 20-30 hours researching this, okay? Not a typo. So I'll show you how this resistance measurement is done. It's a super straightforward business. And once the instrument is connected all right, then those are the numbers we're looking at. 222, 223 kilo ohms. You can see the kilo ohms abbreviated in the corner. And I have actually taken measurements on everything. So on the yellow stickers from here on you will see all of the numbers I recorded. So that's those two things. The next two things are in the corner, and those are emission related components. This guy here, just right here, recognizably next to this suspension upper mount here, there are three pieces of wire for that connector and 2 pieces of wire for this connector. Okay, they are connected to the Egr system, the exhaust gas recirculation, and the one with the 3 wires is your Egr boost sensor, and the other one is the boost sensor solenoid. This has 2 wires to it, and it should be 22 to 26 ohms of resistance, and I measured 39.2, slowly failing. The previous one I just measured, I measured 217 a few minutes ago, so we just read 222, 223. Either which way, it's in the kilo ohm range. It's failing slowly, everything is slowly failing. This is what I measured on that one, a little too much. I measured 40 ohms on this one, still functions, so many kilo ohms. It's not functioning really well. I'm getting all kinds of error messages, and especially also on this one. I measured 500 kilo ohms on that. So on the Egr boost sensor, it's got 3 pins. You gotta measure voltage, and vacuum needs to be applied. So it's a pressure type measurement. It's just vacuum, pressure, whatever, same thing, back plus and minus. And you need to hook it up to the computer. Okay, so don't bother. The next one we're going to look at is the knock sensor. The knock sensor exits from this main cable harness here, and this is the connector that leads further down where the knock sensor is. The knock sensor is that way next to an air filter, next to the oil filter, and it's super hard to get to. I just disconnected it here. I measured its resistance, and I found it to be 561 kilo ohms on mine. It should be between 532 and 588. 561 meets the specs. The next thing, and I'm gonna get back to these fuel components there. I just turn this one off and maybe put this one on the ground here. If you follow this harness here, it comes here. This is your camshaft position sensor. This is where the camshaft lives under the cam cover. Alright, your timing, camshaft for exhaust and intake. This is your camshaft position sensor. 2 wires lead to it. 2 wires means 2 terminals, like so. Super easy to hold. 2 probes on it, measure its resistance. The next guy here, oh, this is all brittle, look at that. That's electrical tape, 15 years old. The next is this thing with 3 wires. These 3 wires go further down, and they lead to the crankshaft position sensor. Okay? And even though, just as with the knock sensor, this is not the sensor itself, you can still measure resistance wherever you are at this level, and it will be still a valid measurement. Look, this is what I measured for. That's for my camshaft position sensor. It should be between 0.95 and 1.25 kilo ohms, and I measured 1.096. Now in this picture I got 3 terminals. That's what came out of the manual. On mine I only have 2 terminals and 2 wires. Super straightforward, yet that number still is, that many kilo ohms is still within the range. For the crankshaft position sensor I do have 3 wires, and I measured 553 between one of them and the middle. So both the camshaft position sensor and the crankshaft position sensor down there are part of the ignition system components and are part of the engine electronics. But the rest of the wires exiting from the same leg of the wiring harness are not part of the engine management, but are part of the engine related vehicle electronics. So we're going to include them in this video. If you follow this black jacketing, you'll see two single wires exiting from it. Both are leading to a simple mechanical switch. By mechanical switch, I mean something like this. On a mechanical switch, typically there is a plunger, and displacement on the plunger opens or closes a circuit depending on how the switch is wired up. Typically, the plunger's displacement is against the spring. You can see that spring being compressed when displacement on the plunger is produced, and then the plunger returns to its normal original position. So that's exactly what's happening on the end of this next wire. It's leading to this unit here. This unit is your power steering pump. It's got a big pulley wheel. It's driven by this V-belt, and you can see lines going to it from the power steering fluid reservoir. So what happens inside this power steering pump is the pump pressurizes the power steering fluid, and the pressurized power steering fluid produces this displacement on a mechanical switch. Just this is from a motorcycle, but it's the same principle. Alright, so that's why you only have a single wire leading to it, and that's what's at the end of the wire. The other one is also similar in principle, goes through a coupling there, and then if you follow it down, it's going down there. You can see refrigerant lines connected to this unit here. This is part of the air conditioning system, and this is your air conditioning compressor. This wire leading to a magnetic clutch is an electromagnetic switch, but it's still a switch. Alright, one more mechanical switch on the air conditioning system happens to be found on this part of the vehicle here, right next to the headlight on the driver's side. If you look down there, these two refrigerant lines lead to that cylindrical or circular unit. At the end of it, it's a cylindrical tank for drying the refrigerant, and yeah, this is the refrigerant dryer / receiver, and on top of it you can see there is some wiring harness going to it, and maybe you can even see there's two pieces of wire going to it, and it's hard to see and it's dark down there, but you can barely see those two pieces of wire. This is your refrigerant pressure switch. This pressure switch is possible to test. There are trouble codes for it in the vehicle's computer, but to test the switch you would need to set pressure accurately within whatever specifications, and you'd need to check continuity between different legs on the circuit as it relates to the certain amount of pressure exerted by the refrigerant. Okay, so it doesn't have resistance, okay, it's tested differently. I just wanted to mention it. It's just next to, or coming out from a wiring harness that has the headlight and other components on it, not engine related stuff. So let's get back to the engine electronics parts. Now this has been pre-loosened here. Everything has been here pre-loosened. It doesn't come apart this easily. But let's start here with your high tension lead. This is your high tension lead, and you can measure resistance there on the metallic parts. You can see super straightforward, and that's your high tension lead. Now this is cylinder number 1, cylinder number 2, cylinder number 3, and number 4. So this is your high tension lead number 1 because it's leading to cylinder number 1. It's a longer wire than high tension lead number 3 on cylinder number 3. Shorter wire, less resistance, longer wire, more resistance. Okay? Alright. specs are here. High tension lead for the number. It's different for the ZM engine than the FS engine. I'll explain it in a sec. But the ZM engine is 1.6 liter, and the FS engine is 2 liter, 2.0. The FP engine is possibly it is 1.8 liter engine, but I didn't find any specs in the manual. I only found ZM and FS. So the FP engine, possibly the same specs as the FS, but it's sheer guesswork. So don't take my word on it. Don't find your own FP numbers. So the number one lead, 3.3 to 7.8, is more than the number 3 cylinder, the shorty, because that's only 2.9 to 6.8. So 6.9 is less than 7.8. So there you have it. The same for the FS engine. This is an FS engine, and everything is kilo ohms. And I measured those figures, 0.9 and 0.36. My high tension leads are aging, and they have a much less resistance, so they are, I guess something is breaking down and is becoming more conductive. So FS engine versus ZM engine. This one is a 2 liter FS engine with the oil filler cap found here on, we'll go for the right hand side if you look at the engine this way. On the ZM engine, the 1.6 liter engine, the filler cap is found on this side. So that's the visual differences. Other than the high tension leads, the next thing that you have is this. This is your coil, ignition coil, and you can measure two things on it. Between terminal A, which is that one on the bottom, you get it, that one on the bottom, terminal A, and the case, like so. The case, you can measure resistance. The case should be insulating enough. The specs says that you gotta have, let me just bring it here. The specs says that on the case you gotta have, between terminal A, you gotta have at least 10 mega ohms, no matter what kind of engine you're using. The only figure is 10 mega ohms, and I say it's a minimum of 10 mega ohms of resistance because it should be insulating efficiently. I measured infinite. The instrument says OL, as in overload, because it's fresh, it's new, it's really well insulating, so it's way more than 10 mega ohms. It should have infinite resistance. You can also say mega ohms or kilo ohms. If you don't want to say kilo ohm or mega ohm, just mega ohm, same thing. Depending on where you live, it does change. Last measurement is your secondary coil winding. You have to measure resistance between that point where you hook up your high tension lead and that point where you hook up your spark plug. So the spark plug goes there inside the engine. The spark plug goes in first, and this one just snaps on. The resistance figure for secondary coil winding, and this coil is the same as this one for both cylinders, so there is no cylinder 1 or cylinder anything else. The secondary coil windings are different for the ZM than for the FS engine, and again I don't have a number about the SP, so the numbers are 8 to 12 kilo ohms for the ZM engine and 7.2 to 10.8 kilo ohms for the FS engine, and you measure it between cylinders 1 and 4 and 2 and 3, and that again means that if this one is in here, this one is powering cylinder 3, so you measure it between 2 and 3 there. So you, one in one hand, the other one in the other, and you take a reading. And the last thing you can check out is the spark plug itself. Just turn around here and you can measure the spark plug's resistance this way. You take the whole spark plug and touch the top of the electrode, and then watch the bottom, because you don't want to touch the grounding. That's not good. You need to touch it there on the round part where the electrode that runs in and comes out at the top and is exposed at the top runs all the way in underneath this porcelain insulator and comes out at the bottom. So that's one piece of metal there, but is insulated away from this threaded part and the ground electrode. So if you try to measure it between the top and the side, that's not going to result in anything. You have to measure it and poke it carefully there, just like so, without contacting the ground electrode, which is here. So that's no good, that is good. Okay, the specs for a good spark plug: if you have NGK or Denso spark plugs, it is between 3 and 7.5 kilo ohms, and on a Champion or Mazda spark plug it's between 5 and 15 kilo ohms. So you look at it, this one is NGK and its number should be between 3 and 7.5. Let's just check it real fast. There, 4.27 it is. That's within specs. Next one, we're going to look at the fuel injectors. The fuel injectors, 4 pieces, live here. 1, 2, 3, 4. I know you can't see much, but you can this way. The gray connector needs to be pulled off, and the fuel injector is the green item there. And there are 2 pieces of wire leading to it. There, those 2. You're looking at it full on. And you can measure resistance on the terminals. And on the ZM engine, the 1.6 liter, the only number I found is approximately 13.8 ohms. That's the only figure I found. On the FS engine, 2 liter engine, it's got a range 14.2 to 14.8 ohms. End of story on that one. Moving on to this side of the wiring harness. So we're done all there. On this side of the wiring harness, we've got, and maybe I moved some of the cables away, and now you can have a better look at the EGR sensor, this round black thing that I tried to get a good shot, but now you have it in full view. Okay, that's the EGR sensor. So moving on this side of the cable wiring harness, you have a ground point there. That is, something is being grounded there. The next item is this gray little thing. It is plugged into this hose, which is connected to the engine coolant. This is your engine coolant temperature sensor. There, engine coolant temperature sensor, and its resistance changes according to ambient temperature. At 20 degrees or 68 Fahrenheit, it should be between 2 and 2.9 kilo ohms. I just measured it, and that number is 2.38 kilo ohms that I just measured. Splendid, because it's 25 degrees outside. So technically speaking, this coolant temperature sensor is not really part of the engine management, because it's neither part of the fuel system, nor the air system, nor the exhaust system, nor the ignition system, but is an electronics component, and it's sitting on top of the engine. Actually, anything exiting this leg of the wiring harness is not really leading to the engine anymore, but I'm going to include them because they are electronics component, and for most of them trouble codes exist. So we'll get going with the video. Right next to it is this black unit with these 2 wires leading to it. The connector comes off, and this little unit is actually not really connected to the engine. If you look at it, it's just sitting on a bar or a piece of steel right next to the engine. This black unit is a radio component. This is a condenser. It has to do, what it does has to do with signal interference and radio signal interference, that is. That's why it's sitting next to or close to the ignition system components. Okay, not because it needs to be next to a source of heat coming from the engine. It's is providing a clearer radio signal, okay, from the biggest source of radio interference, the ignition system and the ignition coil packs. And next to it there's another grounding point, so that's just a grounding, some component is grounded there, I don't know what. You can look at the same idea with the battery. Here is the battery, there's a grounding point there. That's how these look like, just there's nothing to do with it. Next one, exiting from this wiring harness, is these two lines, and they are one gray, one black. They have 4 wires in it each. There. Well, it's not super nice, but you can see that there are 4 wires in it, and they are going to your oxygen sensor, one upper, one lower. And these oxygen sensors are heated. I know you cannot see the other oxygen sensor, I'm just showing you the cable keeps going, and there's another oxygen sensor that lives further down, who knows where. There you can just barely see it at the end of it there. Okay, oxygen sensors. These are heated oxygen sensors, and the heating circuit can be checked. The specs on the heated circuit, and you need the picture from the books from the library, okay, because it does matter if you're measuring at the front of the sensor or the rear of the sensor. It's approximately 5.6 ohms and approximately 15.7 ohms between terminals C and D, and you have to look at it which one is C and which one is D, because you're going to be rotating it from for measuring from the front and from the rear. So, and the pictures are really similar. They're different, but they are really similar. I can't copy or whatever, so you have to look at it. The last itty bits of wire that exits this harness is leading here. 2 pins go into that sensor, and and that sensor is sitting on the transmission. So the last 3 sensors have to do with the transmission. This was your engine so far. This part here is your clutch. There's nothing to do on the clutch. Whether it's automatic or manual, it's a clutch thing for now. And so that's sitting on the transmission or transaxle. So that's sitting on the input shaft, and it's measuring RPM on it. That's your input or turbine, because things are spinning. That's a turbine speed sensor, where speed is RPM, revolutions per minute. And between minus 40 Celsius and 160 Celsius, or minus 40 Fahrenheit and 302 Fahrenheit, it should have a resistance of between 250 to 600 ohms. I just measured 351. I'm jolly good on that one. And that's not a typo. Negative 40 Celsius is negative 40 Fahrenheit. That's not a typo. The next one, and these are the most complicated ones, those 2 fellas sitting side by side. One of them is round. Oops, I'm stuck. One of them is round. You can see the one on the left is round. So let's try zooming in that one, and it has 9 wires to it. The other one is rectangular there, and also has 9 wires leading to it. So let's take a look at the round one. Those are your shifter solenoids and your transaxle. The transaxle fluid temperature measurement is taken there as well, and those are your shifter solenoids, and those are that's your transmission transaxle switch. I'll show you what we're looking at here. So your shift solenoid specs are also described in terms of the same temperature range between negative 40 Celsius and 150 Celsius there. Maybe that should be a 160, my typo. And the solenoid, the shift solenoids are labeled A, B, C, D, and E. And the solenoid labeling is not the same as the terminals. You really have to look at a picture, but if you start measuring random resistance, you should find 3 of them that measure between 1 and 4.2 ohm, 2 of them that measure between 10.9 to 26.2 ohms, and 1 of them that measures between 2.4 and 7.3, and that's your pressure control solenoid. And the last one, last combination within the same round socket of 9 things, one of them that's a thermistor and is resistant to resistant changes according to temperature, and you should be reading a 33.5 to 42 ohms of resistance on one of those where the transaxial fluid is wired in. On the rectangular one, like I said, that's your transaxial range switch, and you don't measure resistance there, you measure continuity in different combinations. The transaxial range is shifting from park to reverse to drive to neutral and whatever, and you should be measuring resistance between specific terminals there, like between B and I and D and F and whatever, and it's a continuity measurement, not a resistance. Just as easy, but you have to look at the picture because it's got 9 wires and a bunch of combinations. Okay. So that would be the lay of the land, ladies and gentlemen. I hope you enjoyed the tour. It was fast and furious, and I hope I can help you with somewhat with simplifying and demystifying engine electronics. It's complicated, like I said. It's not a comprehensive course, so just take it as it is. Those are your resistance measurements and values. Now I know from my data that the worst guy is this one and this one, so I'm probably gonna go to the car wreckers and try to find 2 good ones, taking my measuring instrument with me, 2 good ones, and that will bring everything closer to compliance, because that's still out and that's still out, but everything else is pretty good. Yeah, everything else what I measured is pretty good and is meeting the specs, and the trouble codes I do get, like misfire, are all related to these ones. I also get a trouble code like knock sensor, but the knock sensor is the result of these solenoids failing, and then the ignition being off, and then it's pinging and making a noise, and of course the knock sensor picks it up. So that's how my troubleshooting goes here. Have fun.